So my name is Rex Dyer. I'm a legislative assistant with Congressman Tim Ryan, and I would like to take this opportunity to welcome you to today's House Manufacturing Caucus briefing on renewable solutions to industrial heat. This briefing will provide an overview of renewable technology solutions and their deployment challenges, as well as insights from companies engaged in these efforts. This is a particularly timely and relevant topic for the 117th Congress, with RD&D provisions included in the bipartisan infrastructure law, and with the recent movement we've seen of Compete's USICA or CHIPS Plus. Congressman Ryan has chaired the House Manufacturing Caucus since co-founding it in 2003. The caucus seeks to examine policies to help American manufacturers find trained, educated workers to continue to lead the world in developing cutting-edge new industrial technologies, operate on a level playing field with foreign competitors, and obtain the necessary capital to thrive. The House Manufacturing Caucus works to highlight the vital role of American manufacturing in the U.S. economy and to provide an educational forum for members and their staff on how Congress can successfully implement bipartisan policies that maximize American innovation and competitiveness in global manufacturing. This briefing is being recorded. There will be a Q&A after the presentation. We appreciate the pre-submitted questions, and please feel free to drop any questions that you have during the briefing in the chat. Lastly, I would like to thank Chris Kardish with the Centers for Climate and Energy Solutions, as well as Rose Luttenberger and Hunter Hollander with the World Wildlife Fund, and of course RTC, and our panelists for the time and effort they put into today's briefing. And with that, I will turn it over to Chris. Thank you.
Thanks, Rex. Thanks to the House Manufacturing Caucus for having us. I'm Chris Kardish with the Center for Climate and Energy Solutions, or C2ES. We're one of 3 organizations that facilitate the Renewable Thermal Collaborative, which we call the RTC for short. The others are the World Wildlife Fund and David Gardner and Associates. The RTC is a coalition of more than 50 companies and organizations that are committed to accelerating the use of renewable solutions to heating and cooling and manufacturing in buildings, which is a huge source of energy use in the US and globally. They're committed to doing this because they want to decarbonize their operations and protect their long-term competitiveness in the low-carbon markets of the future. Our members are companies and organizations that are large buyers of thermal energy, mostly manufacturers who use a lot of heat to produce goods. Our sponsors are technology and service providers that are developing renewable solutions to thermal energy use. Some of them are here today to speak at this briefing. So as Rex mentioned, we're going to go a bit deeper into those leading renewable solutions to industrial heat, their potential, their challenges, and how policy can support their acceleration. I'll start with a short presentation, then we'll hand it over to our panel of RTC members and sponsors. We encourage you to submit questions via the Q&A field at the bottom of the screen, because we should have time at the end to answer them. So I'm going to get started. So it's important to start by distinguishing thermal from electricity. Thermal energy is largely produced by combusting fuels at a factory or building and then used in heating or cooling processes to make goods or heat buildings. So for manufacturers, this could mean heating water to use in a production process, steam from a gas-powered boiler, or direct heat for an oven or kiln to transform raw materials. Thermal energy accounts for about 50% of final energy use globally and roughly half of US industrial emissions. Relative to electricity and transport sectors, industries received less attention, but that's starting to shift. For one, we're seeing interest in carbon tariffs on industrial materials like steel and cement in the US and abroad. Europe is likely to become the first region with the carbon border adjustment starting 2023. There's momentum behind the Buy Clean movement, where governments adopt rules on the emissions intensity of materials used in public projects. The GSA became the first federal agency to do so this year. 5 states and localities have passed Buy Clean laws, with many more considering legislation. And of course, there's a lot of recent federal legislation focused on or including support for research, development, demonstration, and deployment of solutions for industry, including the bipartisan infrastructure law. Our work is cut out for us, though. As you see on the left, industrial emissions are nearly a quarter of US greenhouse gas output in direct terms. This number is expected to rise without significant action, making industry the largest source of US emissions by 2030. And then as you see on the right, only about 10% of industrial heat demand is met with renewable energy, with natural gas the current leading source at around 40%. Complicating this challenge are the varying temperature demands that manufacturers have for their production processes. About half of those needs coming from high temperature ranges above 400 degrees Celsius. And this is heat that's largely needs to be produced on site and can't travel across transmission lines like electricity. So these factors present constraints on the options for alternatives. Fortunately, there are many alternatives available though. So the RTC is working to accelerate options ranging from biofuels to green hydrogen and solar thermal. And what I'm going to do now is take a closer look at some of these options, and then our panel of companies will dive into how they're thinking about them. Biomass is something many of you are likely familiar with. It's organic material that's either combusted directly for heat or electricity, in the case of solid biomass, or refined into liquid fuels or converted into biogas, which I'll talk more about in a second. So biomass actually encompasses a lot of things. Wood and wood waste is the most common form, but there are many sources, as you can see on the right. The most common application of biomass is heat, and it accounts for roughly 70% of renewable energy use for heat. Industry accounts for roughly 50% of that use currently. It's attractive because it can meet various temperature demands and is already a proven solution in industries where it's, at least in many contexts, a proven solution. In industries where it's available as a waste byproduct, there's already significant use, like tobacco and paper. But its overall growth over the last decade has been significant. Looking to the long term, the role of biomass for industrial heat is likely to be significant, but potentially limited by factors such as its overall availability, land use competition, and sustainability concerns. Alternatively, biogas systems recycle organic waste using a natural process known as anaerobic digestion. Biogas can then be further refined to the point where it's functionally interchangeable with natural gas. We call this renewable natural gas, or RNG, and it's compatible with the existing pipeline infrastructure. The environmental benefit lies in diverting waste as opposed to using new natural gas. So this is waste that would otherwise occur as methane emissions, a very highly potent natural greenhouse gas, but by combusting it for an industrial process, it's instead released as carbon emissions. And again, you're avoiding a lot of methane emissions from waste. What makes biogas and especially RNG so attractive to a lot of large heat users are how compatible they are with natural gas's use in existing processes. That said, we have a lot of untapped potential. There are just over 2,000 sites in operation now across wastewater treatment, landfills, farms, and food sector waste. But there are likely another roughly 15,000 sites available, with the potential to replace about 7% of US natural gas consumption while creating jobs in the process. For context, Europe has about 5 times the biogas systems the US does. So there's plenty of room for work there. Beneficial electrification, put simply, is the replacement of technologies and processes that run on fossil fuels with those that are powered by electricity, and ensuring that that electricity is clean and renewable. Industrial electrification it's a pretty broad term actually that encompasses a lot of different technologies, some of which are available today, some of which are still in development. Some examples that are available today include electric arc furnaces to produce steel and other metals, many of you have probably heard of, electric boilers to generate hot water or steam, and industrial heat pumps. Electrification has huge potential overall, but tends to vary by sector and region, and even at different facilities within the same company. It's generally more challenging to do cost effectively in high temperature applications, and also for sectors where different processes are highly integrated. Many of you are probably hearing more and more about green hydrogen and its various other forms. It's produced with water and renewable electricity using a device called an electrolyzer to split oxygen molecules from hydrogen molecules. It's really appealing because of its potential to decarbonize a number of the heaviest emitting industries and processes, including petroleum refining, fertilizers, food processing, and steel. Right now, green hydrogen is a lot more expensive than traditional hydrogen from fossil fuels. But a lot of analysts estimate that it can become cost competitive within a decade. And a lot of countries, including the US, through the bipartisan infrastructure law, are pouring a lot of money into R&D to achieve that, largely by focusing on reducing the cost of electrolyzers and improving their efficiency. Very generally, solar thermal technologies repurpose heat from the sun using a collector made out of different materials depending on the type and the temperature range of the system. They're ideal for low and medium temperature industrial processes, but more novel solar thermal systems can reach even high temperature applications. It's estimated that there's technical potential for solar thermal to meet 10% of industrial energy demand by 2030. And that's in part because it's a deployable solution for many major sectors in the low to medium temperature range, like food and beverage and paper. Then finally, thermal storage is an emerging and exciting technology type that captures renewable power during off-peak times and converts it to heat for direct use in manufacturing processes or storing it for later. As with typical battery storage, you're decoupling renewable availability from the time when energy is needed and taking advantage of when it's overabundant and cheap. Unlike lithium ion, thermal storage uses large containers that are filled with commonly available materials like ceramics, metals, and minerals to store heat. This is a relatively new technology with very low market penetration, but one with significant potential, even to decarbonize high heat processes cost effectively. So despite the promise of renewable thermal technologies, there are numerous barriers to scaling up. You could break them into three buckets. With supply, geography can be a constraint. So for example, certain areas have limited access to biomass materials or adequate sunlight exposure or geothermal potential. Then there's also often this sort of disconnect between demand and supply, in part because it's difficult to transport fuels like biomass and hydrogen over large distances. And these supply challenges also mean it's hard to reach scale, which ultimately is something we need for cost effectiveness. Then there are numerous market barriers. Renewable technologies, of course, have to contend with low natural gas prices. That's a big one. Then unlike renewable electricity, which has long had renewable electricity credits and other sort of market instruments, there's a lack of market instruments for purchases of renewable thermal sources to help with investment in scaling up. A low turnover rate for heating capital means that there are fewer opportunities to replace that capital stock and deploy new technologies at scale. Then to move to policy, there's really what we see as a patchwork of state policies and a general lack of federal buy-in despite progress. So there's some state level action like tax incentives and some use of renewable portfolio standards on thermal, but these programs are often limited and only available in certain places. At the federal level, financial incentives remain limited, and historically, the overall policy focus has been on the electricity and transport sectors. State and federal policy could definitely help address some of these challenges. We're definitely seeing steps in the right direction through legislation like the bipartisan infrastructure law, but we think a lot more is needed. To highlight two areas where the RTC is most active, we see need for more robust financial incentives for renewable thermal solutions and greater support for research, demonstration, and deployment of technologies. So renewable electricity has benefited greatly from policies like investment production tax credits, but we haven't seen that kind of focused financial support for renewable thermal, where many of the solutions are still nascent in terms of their market penetration. And we likely need broad-based support for these solutions because, as you can tell from this presentation, no single option is going to be a silver bullet. DOE offices are increasingly engaged on demonstration and deployment, focused on industry, but we need to continue supporting budget increases and programs under offices like the Advanced Manufacturing Office and Hydrogen Fuel Cell Technologies Office and many others. So we're now going to hear more about the successes and challenges companies face with renewable thermal deployments, as well as policy needs from our panel. I'd like to start by introducing our moderator, who will then introduce the panel. So Blaine Collison is the executive director of the RTC and a senior vice president at David Gardner and Associates, which is a climate and energy consultancy that is one of the 3 organizations that convenes the RTC. So he's had a long career spent working to advance renewable energy, both at the EPA and at Altenex, an Edison energy company, before landing at David Gardner and Associates. So with that, take it away, Blaine.
An opportune time to clear my throat. Thank you, Chris, and thank you, Rex, for having us, and thanks everyone here in the audience for taking some time today to chat with us. So let's get straight at it here, right? Because the thing that gets particularly interesting in all of the context that Chris just laid out is how companies are actually trying to navigate this series of complexities as they implement broad decarbonization, innovate technology, right, and facilitate change. So I am joined by three very smart, insightful folks here. Rachel Goldstein is the North American Public Policy Director from Mars. Rachel leads advocacy on a variety of policy issues there relating to Mars' Sustainable in a Generation plan. That's actually a pretty interesting reading. I encourage you to have a look at that. In 10 years at Mars, Rachel has held roles on the central sustainability team, specifically covering plastic packaging issues, and led sustainability for science and regulatory affairs. Rachel has an MBA from GW here in town, and a BS in human factors engineering from Tufts. And Rachel and I were colleagues once upon a time back at EPA. So thank you, Rachel, for joining us today. Inbal Nachman is the Government Relations and Marketing Director for Skyven Technologies. Skyven is a really interesting advisory company whose mission is to decarbonize thermal energy in manufacturing, working directly with manufacturers to design and implement decarbonization strategies at scale. Inbal has been at Skyven for about 3 years, I think, and has led communications and advocacy on the challenges and solutions around industrial decarbonization. And Inbal has an MBA from INSEAD, sorry if I got that wrong, and a BA in anthropology from the University of California, Berkeley. Go Bears. Lastly, we are joined by Andrew Jarrick, who is the Environment and Sustainability Manager for Diageo, a beverage alcohol company and alcoholic beverage company with a product portfolio that I think will be familiar to a lot of our participants here today. It includes Smirnoff Vodka, Captain Morgan Rum, Aviation American Gin, and Guinness Blonde Beer. I confess that I have a number of Diageo products in the cabinet downstairs, and they are tasty. Diageo's U.S. manufacturing locations include distilleries in Illinois, Kentucky, Oregon, Tennessee, and the U.S. Virgin Islands, as well as a brewery right outside Baltimore, Maryland, there in Baltimore County. Andrew's got 15 years of experience here in environmental regulatory compliance management, energy management, and sustainability across heavy equipment manufacturing, automotive supply, and food and beverage. At Diageo, Andrew works closely with the company's manufacturing facilities in the US and Canada, helping to manage their efforts to achieve their ambitious environmental sustainability goals, particularly focused on reducing carbon emissions, conserving water, and preventing waste. And Andrew is today on site there at the Stitzel Weller Distillery in Louisville, Kentucky, where Diageo makes Bullet Frontier whiskey. So welcome to all of you, and thank you again for being here. So let's let's get straight at it. And let me start with Mars and Diageo and ask each of you just to say a little bit about what in fact your companies do and the ways you're using thermal energy in your operations. And Andrew, we close with you, so let me start with you here to work back.
Fantastic. Thank you, Blaine. And thank you to the House Manufacturing Caucus and the Renewable Thermal Collaborative for allowing us the opportunity to speak on Diageo's progress and approach towards decarbonizing our American manufacturing. Diageo owns and operates manufacturing operations in 5 states and the U.S. Virgin Islands. Each of our sites uses thermal energy to produce our American-made products. Adding and or removing thermal energy is critical to almost every step in our manufacturing process. So I'm here in Louisville, Kentucky, where we do use high volumes of thermal energy in the form of steam to transform our grain into whiskey. There are 5 major steps that require thermal energy to produce whiskey. These steps include cooking grain to maximize starch conversion to sugar, the fermentation to allow yeast to convert that sugar to alcohol in the form of beer, and then that beer is distilled with high volumes of thermal energy to separate the alcohol from the water and solids. Our spent grains are dried using thermal energy driven evaporators and grain dryers, while the alcohol is then laid to rest in new charred oak barrels for years to come. And once the whiskey is ready, the blending and bottling process uses steam to clean and sanitize to ensure high quality is delivered every time. And each of these steps, as you can see, requires significant amounts of thermal energy. Traditionally, that thermal energy that's been required has been generated from fossil fuels like natural gas, heating oil, and coal, and accounts for approximately 80% of our direct greenhouse gas emissions in the U.S. And our plans for decarbonizing move us away from those traditional fossil fuels towards renewable thermal. Thanks, Blaine.
Thank you, Andrew. Rachel, please.
Okay. Thank you, Blaine. And also thank you to the RTC team and the House Manufacturing Caucus for your leadership and inviting me to talk about renewable thermal policy. So it is my great pleasure to be here on behalf of Mars. And for those of you who may not be familiar with Mars, we are family owned and privately held. Our global headquarters is in McLean, Virginia, so about 15 miles west of the Hill. And we have a pretty diverse portfolio, but I think you'll find many familiar brands. So M&M's, Snickers, and Twix. For those of you who have spent more time with your pets in the last 2 years or welcomed a new one into your home, we're also a big pet care company, pet food, and veterinary hospitals. And then we're a food business that's non-confection, non-chocolate. So Ben's Original, Tasty Bite, Seeds of Change. We have about 130,000 associates around the world, more than 60,000 of which are in the United States, and that we manufacture in over 30 factories here in the US. And I mention our portfolio not just to acquaint you with the business, but it's really to highlight not with just the diversity of products, but that they need different manufacturing processes to produce, and want to bring that more to light in light of today's conversation on renewable thermal and policy. Overall, the work of the RTC aligns with our corporate sustainability goals. As Blaine mentioned in the bio, in 2017, we launched our Sustainable in a Generation Plan, which is our full value chain set of commitments. But as back as far as 2008 and 2009, we set a goal for 0 greenhouse gas emissions and 100% renewable energy for our direct operations by 2040. We also have an interim goal to reduce our operational emissions 42% by 2025. And globally, we've made good progress on those direct operations. More than 54% of our electricity in our operations is from renewable sources, and we switched to 100% renewable electricity in 11 countries. So the plans to make that switch to another 8 countries by 2025. But as Chris talked about in his intro, is that the role of policy and the role of incentives has helped us make this progress in electricity. But we have thermal needs as well. So let's talk a little bit more about that. And I mentioned in our manufacturing processes, we need those to make the products that people and pets love. About 60% of our energy usage is thermal versus the 40% electric I just mentioned. And that's a ratio that's about US and global. And so our involvement here with the RTC is because we really need to find renewable thermal solutions for that remaining 60%. And so our manufacturing processes involve mainly two areas of thermal. So we think about hot air, like a big convection oven, and steam. And to contextualize this a bit more in terms of our operations, one, we need to roast cocoa beans in the chocolate making process. Two, we need a lot of heat for our pet food manufacturing. So currently we're using natural gas in many of our operations to generate steam or to generate heat, to dry or to bake the product. Three, we use steam for pressure cooking for wet pet food and our rice portfolio. And then for overall steam for just overall sanitation. And then lastly, we've approached thermal in a couple different ways where we're looking to start to be as efficient as we can, looking at our processes and our equipment to see where we can reduce just energy use overall. Can we think about electrification, as Chris talked about in his intro, but we can't move to electrify everything. So again, here we want to talk more about the opportunities for renewable thermal. And back to you, Blaine.
Excellent. We could dive in 7 or 8 different places here so far, and we're just getting warmed up. So Inbal, Skyven sits in a slightly different role and position in the market. So I'd love for you to give us a little more context on Skyven, who you are, what you do, and what you see as a result.
Yeah, absolutely. First of all, thank you, Blaine and the House Manufacturing Caucus for inviting us to speak today on a subject that is very near and dear to my heart. So I appreciate all of you. So Skyven partners with manufacturers to realize projects that decarbonize their thermal energy. We guide large manufacturing facilities through the complications of reducing CO2 emissions. And there are really a lot of consultants in the decarbonization world. We're not one of them. We're a projects company. So we design, fund, and build thermal energy solutions specific to a facility to help meet its climate goals. Then we manage and maintain the project every step of the way. So typically when we start engaging with a manufacturer, we first identify scope 1 emission opportunities to reduce thermal energy. These opportunities fall into 3 project buckets. The first one is energy efficiency, the second one is electrification, and the third is renewables. We then design specific solutions that are unique to a particular facility, and we build financial flexibility into the package since Skyven can fund projects at no capex. In fact, we bill on energy savings so manufacturers can trust the value of our services. Finally, we measure and verify actual savings while providing project management support throughout our partnership. Our whole model is based on aligning incentives. We don't make money until our customers save energy. So it's really important to note that our business and our mission go hand in hand because we want to see a world where manufacturers build resiliency as our world continues to change. Back to you, Blaine.
Fabulous. So a couple of things I notice here as we get ready to dive in a little deeper, right? So we're talking about some technology change across complex manufacturing portfolios, right? I mean, Rachel and Andrew are running multiple facilities. They're 130,000 employees around, right? And there's a lot of physical operations here that have to be engaged, right? As we think about deploying these changes, and then certainly one of the things we're going to wind up chatting about here as we talk about barriers will be cost. Right? What is the cost of these technologies and transitions and deployment and implementation and scaling? And Inbal has already flagged some really interesting business model elements here in the market, emerging in the market, that actually sort of take us back in some ways to some of the renewable electricity experience and what's made that possible, right? The ability to do bundled third-party finance to stabilize energy cost, lock in savings, to take the capex piece out of the equation. These are all worthy of deep discussion by themselves. So we're gonna wind up touching on some of these themes over and over again, I think. So on the technology side, Chris showed us a slide of 8 technologies, right? They're decarbonizing thermal is a multi-technology question. So Andrew, Rachel, as you all are looking at your specific operations, are there particular technologies that are especially interesting that you're thinking about, and why? If there are, why? And Rachel, how about if you get us started here?
Okay, so thanks, Blaine. And I think I'll almost take a look at it from what are the things that we need to achieve with the thermal needs that we have. So I'm going to answer a little bit more on the angle of the food company that we are, right? So, and a key challenge for us is food safety, and the high heat is very relevant to that, so that we need to preserve the quality and safety of our product. So it's not quite as easy as just finding something else to burn during the process of generating heat, but that we need to find something that can replace natural gas safely and cost effectively. But within that context, from a technology standpoint, we are open to any technology. We want to find really a fit for purpose type of technology based on the location. Chris had mentioned something, there are location constraints for certain technologies. And also the availability of different feedstocks that match our processing needs, and at the same time managing cost and efficacy. And then I'll just say, lastly, we do think about the technologies differently. So in terms of what's a short and long run timeline. So, or if you think about technologically ready. So we think of a first tier is something that's proven technology. So like landfill gas, some of the biogas, we know how to do it. We know it works. But the economics and the location can still be a hurdle to implementation. They might need just that extra push. Second, maybe less developed, but available, but maybe even more location constrained. So like solar thermal or geothermal. And then I think third, we look at more like what's more research, right? So there's a significant cost gap, a significant implementation gap with a stronger need for research. So something like hydrogen, for example.
Andrew?
Thanks, Blaine. And so I'm first going to tell us a little bit of a story about a site that we recently opened. So 1 year ago, Diageo opened a new fully electric distillery in Kentucky. It operates using 100% renewable electricity sourced from wind and solar. As compared to the traditional fossil fuel generated thermal energy, this greenfield site creates the heat needed using high efficiency electrode boilers, operates with all electric vehicles, and has deployed virtual metering technology to advance data availability in the name of resource efficiency. Truly a factory of the future. Our new distillery has provided invaluable insights for us to deploy beneficial electrification into the future. Most importantly are the impacts that an electrical load of this size has on the electrical grid, and how the electrical grid infrastructure impacts our ability to achieve decarbonization goals through beneficial electrification. Now, our partnerships with local utilities like Eastern Kentucky Power Cooperative and Inter-County Electric Cooperative were essential to bring this ambitious project to life. Electrification of the thermal energy will allow this Diageo distillery in Kentucky to avoid approximately 117,000 metric tons of greenhouse gas emissions annually, or the equivalent of more than 25,000 cars per year. Now, the reason we are investing in renewable thermal is grounded in our 10-year action plan to create a more sustainable world. In 2020, Diageo launched the Society 2030 Spirit of Progress Action Plan. As part of this action plan, we have committed to eliminating greenhouse gas emissions from our direct operations by 2030. Diageo is part of a group of organizations that are championing a green recovery and supporting the United Nations Sustainable Development Goals. through memberships in the United Nations Global Compact, We Mean Business Coalition, and other key global advocacy organizations. And so renewable thermal energy technologies like beneficial electrification or renewable natural gas, biomass, and hydrogen, right? They offer very different challenges and benefits. And each of our memberships and partnerships provide guidance and help to inform that decision-making process for the best site-specific decarbonization pathway. Right? So we've identified those site-specific pathways. We've identified various different bridge technologies that will allow us to gap from where we are today to where future technologies may have been developed and become fully commercialized. We launched a program called Diageo Sustainable Solutions. And Diageo Sustainable Solutions is essentially an incubator for commercialization of technologies. And we challenge organizations to submit applications to our webpage and tell us how they can best address challenges like renewable thermal or packaging sustainability, circular economy. And with these, right, we're confident that we're going to be able to identify the best renewable thermal pathways for our business. Blaine, back over to you. Thank you.
So, Inbal, I want to tee this one up to you also, right? Because what are the experiences that we have here in the RTC talking with our members and sponsors and stakeholders, right? Is it that the preferred technology path, varies widely, right? Some companies are deeply interested in green hydrogen. Others, goals are due sooner, right? What can we do now? And almost everyone is having a yes and conversation about technologies, right? And I think Rachel, you flagged this. There's typically on the thermal decarbonization, there's not one technology that's going to do this. We're not simply going to wave a wand and electrify the entire U.S. industrial economy. So, Inbal, as you're talking to companies, are you seeing a technology suite? Are you seeing preferences? What's your experience been?
Yeah, it's really interesting. We just heard from Rachel and Andrew, like you said, Blaine, that companies are actually thinking about technologies in a very nuanced way, which is, I think, the way to go. It's really not going to come down to one specific solution that's going to be the magic bullet. We're finding that customers are excited about and actually deploying proven technologies that, like Rachel and Andrew pointed out, that fall into the category of the thermal energy efficiency and beneficial electrification technologies. We often find that some customers think that they have already deployed these technologies and have maximized those opportunities, but in fact, there are still a lot of big opportunities to be had. So after our customers are made aware, they become interested in implementing because they may even save some operational expenditure. So these projects, in many cases, can pencil very nicely. We find that in the front of emerging technologies, customers are quite excited about carbon capture and hydrogen and so on, but it is rare to see, no one is actually deploying these technologies because the state and logistics, the state of the technology just isn't there, and the economics don't make sense yet. So on the electrification side, what we find really exciting at Skyven are high temperature industrial heat pumps, where the heat pumps increase the temperature of the waste heat until it's useful in the plant, and mechanical vapor recompression, so recycling heat in evaporators and distillation columns. On the exhaust, on the energy efficiency side, we have exhaust heat recovery. So we're essentially very excited about repurposing heat that is already leaving the plant as a source of energy. So you can think about it as recycled heat. We see that these are underutilized technologies that are available today, and they can significantly reduce fossil fuel consumption in industrial facilities. Like I said earlier, we believe at Skyven that we simply cannot wait for the magic bullet solution to alleviate the problem. We have to start taking action with what's available today. So yeah, I think that's pretty much it. It's really important to look at all of these different technologies and see what can fit in each unique situation.
Thank you. So we've had a couple of really interesting questions come in, and I'm gonna take a shot at bundling them a little bit, right? Because we want to start to talk about barriers, right? So Mars and Diageo and lots of other RTC members have set very ambitious decarbonization targets, right? And are working toward realizing them. But as you were trying to now figure out what to do and sort of work through the problem, there are barriers you are encountering, your peers are encountering, there are challenges here. It's not simple and easy necessarily. And so we want to talk about what some of those barriers are and what we can do from a policy perspective. I also want to pull into that some insight about value drivers here, right? Because again, one of the things that we also talk about here at the RTC, these are not just sustainability initiatives, right? There are issues of energy risk management, right? This is one of the things we saw on the renewable electricity side early, right? The ability to lock in long-term power prices, to hedge against volatility. We've seen, unfortunately, a lot of news lately about volatility and disruption and risk, particularly in European gas markets, right? So I'm trying to wrap a whole bunch of themes here together, right? So Rachel, Andrew, start with you. What kind of barriers are you seeing? What kind of policy support do you need? Solutions are you seeing in the market? And Inbal will obviously come to you to particularly talk about some of those structuring solutions. So Rachel, you want to take the first crack at this?
Sure. I'll let's see. So thinking about the last answer I gave in terms of like the different tiers of like technological readiness, right? And so in that first tier where the policy incentives might be just like, how do we just push it to get a little closer to cost parity? So, I think part of our success in getting as far as we have on renewable electricity did involve some of the incentives like the production tax credit or the investment tax credit. And to your other point, Blaine, one of the things that we did, and I saw a similar question to this in the chat, so I'll sort of hopefully address that question, that we don't own the wind farm assets to the projects that cover our electricity. But what we do have is a 20-year PPA with the developer to be the off-taker of that. So it helps, like our role in that became de-risking the investment for the developer, but we don't own the assets per se. We own the renewable electricity credits from that. So, the question that was in the chat around, how did we actually help finance that? But part of this was actually with that agreement. But then one of our other projects, when we had our first renewable, so one of our first forays was a landfill gas project, where again, some of the investment was done by the developer, but we still needed to put up the funds to modify our boiler to actually run on a lower BTU fuel than what we were running on in natural gas. So that was our expense. So that's, again, there are a variety of, I think, of different ways to finance, but the policy incentives that can help do that, even if we didn't take the PTC directly, it helped the developer of the project. And then, in terms of thermal incentives, one of the things that we'll be watching for, certainly we saw the sort of pre-announcement from DOE and from the Advanced Manufacturing Office about a funding opportunity in August, because it covers food and beverage, and what are some opportunities for thermal. So again, where we see the need for policy to help bring some cost parity for things that we think are a little more near term. So hopefully that started answering that question.
Yeah, I mean, Andrew, you've been thinking about these issues, right? And you've built an all new, all electric distillery, but you've got existing facilities to address. How are you thinking about these questions with those?
Yeah, and this is the big question: is how do we overcome some of these barriers? And so, when I think about the biggest barriers to deploying renewable thermal, the top on our list is infrastructure. right? And that in the infrastructure that Diageo doesn't directly own, right? And so to give an example of one of Diageo's solutions that was able to break through several barriers was announced this past November at COP26. And we announced an ambitious project to fully decarbonize one of our oldest distilleries in North America. And at this distillery, located just outside Montreal, Quebec, Diageo has committed to a $94 million investment to electrify the thermal energy required for distillation and bottling operations. This energy source transition is led by major energy efficiency projects, similar to what Inbal had talked about with heat pumps, mechanical vapor recompression, looking at it, optimizing and minimizing the energy required to operate the facility as much as possible. And the project looks to avoid an annual combustion of nearly 21 million cubic meters of natural gas. Now, this project was supported from the beginning by multiple layers within the Canadian government. This government investment will create an environment for energy transition through greater energy efficiency and more robust and reliable electrical infrastructure. Right? So the largest barrier, which I said was infrastructure, in most of our projects, and this project was tied solely to the electrical grid infrastructure and how we can make that, improve that infrastructure, make it more reliable and more robust. The support from our partners in Canada were instrumental in making this investment a reality and overcoming those barriers for Diageo.
Interesting. Inbal, I mean, you're helping clients deploy suites of projects. Thoughts about the barriers that they're experiencing, and frankly, I mean, part of what's so interesting about the work you're doing is you are navigating these barriers, right? And deployment is coming out the other side of that process.
Yeah, absolutely. We, typically find that the challenges to decarbonizing thermal energy fall into 4 buckets, and they're very, very similar to what both Andrew and Rachel talked about. But the first one is that these projects are highly complex. So the industrial sector just displays an exceptional amount of variability and uniqueness from facility to facility. And you can have 2 facilities owned by the same company manufacturing the same products at a similar throughput, and they can still be substantially different. So there's a technical complexity to these projects. The second one is resources. So there is, like we just talked about, the unique nature of industrial facilities just demands sophisticated knowledge and expertise to conceptualize optimal decarbonization solutions for a facility's unique operation, and then to actualize those solutions. So a lot of the times that internal resource just does not exist for many facilities. And in cases where the expertise does exist, they just don't have the capacity to take on the scope of the projects on their own. The third barrier that we see is risk. So we hear from customers all the time, our plant cannot go down. Decarbonization projects are perceived as high-risk projects since energy consumption is key to every process in a facility. And then the fourth and final one, which is what we've all heard already, are the capital costs. So the nature of these projects is that they are large in scope and are often allocated to discretionary spending in operating budgets. We've seen just time and time again how higher priority agendas relating to product quality, throughput, and reliability in the plant just leave no room for energy saving projects. So, I think that on what Skyven has been able to tackle is just take these barriers and one by one try to alleviate the barriers. So, on capital costs, for example, we built this model where if the customers either don't want to spend CapEx, or they just don't have the ability to, Skyven can provide that capital upfront to realize these projects. In terms of resources, we come on and provide the technical expertise and the project management expertise, and we really help to alleviate the risk and take on the complexity of the projects on our shoulders. I got a question on the chat that essentially asks, to what extent can a typical facility currently using a natural gas boiler reduce their emissions without significant financial downsides? And I just want to address it really quickly, because I want to emphasize the fact that you can have a huge variability in impact with these projects depending on the location, the market, the process in the facility. So we've seen projects that can almost completely eliminate natural gas consumption in a plant. We've also seen projects that can only really reduce the natural gas consumption by about 10 to 15%, which we think is still significant. So I think that it's important to note that customers do need to be willing to pay for decarbonization on some level, but there are ways to alleviate that burden, and that's part of our mission at Skyven, is to help reduce both the financial, the risk, and the operational burden on our customers.
Thank you. A lot of us here working within the RTC on thermal decarbonization have experience on the renewable electricity side, right? And so we're off at a lot of the companies. We're early leaders in that work, including Mars, and so we often look back at that because it's been an unbelievably successful transformation, right? I mean, we're not done decarbonizing the U.S. electricity portfolio, but we're well down a pathway here, right? And we started in earnest less than 20 years ago, right? And have moved in that time from renewables being a premium cost product to now, in a lot of markets, renewables are the lowest cost source of power available. And one of the things that was so interesting and amazing about that 20-year development arc was the role of large U.S.-based C&I energy users as some of the drivers of deployment, right? And again, Mars was one of the early actors there, along with several other RTC members. We're in there early and often, right? And using their buying power to in fact drive the creation of utility scale renewable electricity projects. And Rachel, you flagged the PTC and the ITC. I guess in Mars' case, the PTC, the production tax credit, as an important part of the overall financial package that allowed Mars to go forward with their first wind transaction. And so, curious, as you all three of you are thinking about the barriers on the renewable thermal side, right? Tax credits. As an example policy mechanism that might be really important here in the thermal decarbonization space. And so I invite a reaction to that.
I think you've said it. But that is certainly an important mechanism, right? And then, when we think about some of the other opportunities, again, for R&D and technical assistance, other grants, one example, I know Diageo just gave a few examples. We, at the end of last year in Australia, we announced an applied research pilot working with several partners to use hydrogen, right? How do we test this out to provide heat for industrial scale sanitation in our in our food business, right? And so this is something that will, soon be underway, but again, a financial incentive to help us test something that is on that third tier of technologies versus the first that we know work and just need a little financial assistance. So I think, again, we're open to really exploring the ideas of where are those incentives, what are the roles of policy in doing that, and then other ability to do longer term contracts for renewable thermal. I mentioned our 20-year PPA for wind. Are there ways to contract biogas to back to pipeline in the same way that we've been able to do that across the grid? So, just thinking through how do we make this easier for all parties to be able to decarbonize.
Yep. One of the marks of a good online session is the moment of panic when you realize that you're about at time and you've only just started to get to all the questions that you had stacked up. So I'm having that moment, and so I want to give Chris Kardish a chance to come back and wrap us up. And I know that we haven't quite gotten to all the questions, and that's moderator error. My apologies to everyone. But Chris, well, first, my thanks to you, Rachel, Andrew, and Inbal. Really appreciate you taking the time today and sharing your insights. And Chris, do you want to come back in and take us out?
Sure. I'll be very, very brief here. But I guess I just wanted to again thank the House Manufacturing Caucus and all the attendees here today, and of course our panelists. We've heard a lot about the opportunities of renewable thermal solutions and how companies are thinking about them on their decarbonization journeys. We look forward to continuing conversations with you all and other members of Congress on how we can work together to accelerate decarbonization of manufacturing in a way that promotes competitiveness, bolsters domestic supply chains, and boosts affordable and reliable energy. Thanks so much. If you need to get in touch with us, I'm leaving my email in the chat here. And we will be making a recording available publicly on our website. You can also reach out to Rex if you're a part of the caucus. That's also okay. But either one of us. Again, thanks so much, and see you next time.